Hello, Mr. Galindo, and welcome to Computer Science Chats.
Hey,
How are
thank you
you?
for inviting me. I'm very good.
Thank you. So, first, I prepared several questions to ask you. Could you please introduce yourself and your educational background?
Yeah, of course. So I'm Pablo Galindo. My background actually is in physics. I'm a theoretical physicist. Now I switched to computer science 7, 8 years ago. But I used to study rotating black holes before switching. So technically, my background is physics. And yeah, so 7 years ago, I switched from academia. I was doing my PhD at the time, and I switched to computer science. So I work at Bloomberg as a software engineer. I work in the Python infrastructure team when we kind of take care of the experience that developers have in Python in the company. We can go into detail if you want. And apart from that, I do a lot of open source work as part of my work on the Python Steering Council and core developer and other stuff. Yeah, so that's basically the short introduction.
Thank you. So, what is it that inspired you to pursue computing as a career?
So actually, it's an interesting question. So when I was doing my PhD, I actually, as a theoretical physicist, mostly pen and paper, and some of the computers we use these algebraic solvers and whatnot. So like Mathematica and things like that. To solve tensor calculus things. And what happened a lot of the times is that you arrive to these kind of big equations that are not possible to solve analytically, right? Like for instance, Einstein equations, which is more or less what I used to resolve it back in the day. Very few cases have analytical solutions. So what you do in those cases is that you reach to the computer and then you do simulations. Normally numerical simulations. They are quite complicated for different reasons. We can go into detail on why. But at some point, you need to solve this numerically, and the computer is the tool for doing that. It turns out that this is not only quite difficult algorithmically, and from the physics point of view, you need to know what you're solving, but these programs are quite complicated. So I was introduced in the world of computer science very early, in the numerical computing sense. So we used to submit like code to Mare Nostrum and supercomputers like that to do the simulations. So at the beginning as a physicist, most of the code was a bit janky. But I really like programming and coding at the time. So it was a world that felt right at home. We do some coding in the degree. Mostly it was Fortran and C99 back in the day. But yeah, my first language was Fortran 77. But yeah, so I knew a bit of that, but like from a just a basic approach to that. Nothing like structure or like proper data structures and algorithms. But it really felt right like home, and I push it even more and more. And at some point, I say, look, I actually enjoy doing this more than doing physics. And it turns out that in computer science, the kind of like life balance, like work life balance is a bit better than academia. Academia is kind of a very harsh world. In my particular case, it was not interesting anymore, so I switched to industry. I used to say that I sell my soul, but I hope it's not like that. So actually, now I do all the things that I was doing in my PhD in my free time because I still enjoy it. It's just that my livelihood and salary doesn't depend on that, which is quite good, I will say. So yeah, that's how I switched from being a theoretical physicist to software engineer.
That's very interesting. Could you describe some of the activities that you do through your work?
Yeah, so I work in the Python infrastructure team. So mainly what we do is that we provide kind of libraries, high performance libraries, and an ecosystem for the rest of the developers in the company in Python. We technically don't do that much Python because at the end of the day, Bloomberg is a financial company, so we provide financial services to people. And all these things need to be high performance. So normally the core of the thing is done in C++. And what we do is that we either develop or we wrap existing C++ libraries and then we offer them, with a Python interface. That's one of the things we do. We also, the past 3 years, we've been working on developing a lot of tooling. We have open source some of that tooling actually. For instance, there is this memory profiler that we did called Memray. So now it's open source. You can check it in GitHub Bloomberg/Memray. So the idea here is that a lot of programmers in our company have a suboptimal experience doing some task like profiling memory was the case. So what we do is that we leverage kind of our experience and say, okay, how can we provide the best tools in this area? Sometimes we cannot do it because either there is already very good tooling, but sometimes there is a good opportunity to say, hey, let's do something like this. And we are very involved in open source. Like for instance, Bloomberg gives me 50% of my work time to do open source. I work with Van Rossum on the Microsoft team part-time on the Faster C Python project. That is part of my work time. But I do a lot of open source in my free time, probably 2 or 3 times as more as I do at work. But yeah, basically the idea is that the summary is that we take care that people doing Python at the company have the best experience and everything is smooth. We provide either libraries or support, or we make sure that the Python interpreter in the company is as fast as possible. Sometimes that involves like some modifications to the normal interpreter that you will see outside. Sometimes it involves like build processes and whatnot. So yeah, that's the thing. So developing for developers.
Thank you. So what is it that you like most, and what do you find most challenging about these activities?
I would say it's the human part. It's always that, right? Because at the end of the day, we deal with like super hard problems, right? Like we do compilers, we do linkers. We mostly work with the part what normally has been referred to the hardest part, which is not really like anything is hard as you push enough, right? Like doing compilers is not intrinsically harder than doing web development if you go to the real part. So it's not like it's inherently more difficult, right? But like normally the scary things that normally people refer to, we do it all the time. But it turns out that the biggest challenges are always people. It's like dealing with people and making sure that people have a good experience. It's not because we dislike it. On the contrary, at the end of the day, technically our department, for instance, in Bloomberg, and it's the same being a Python core developer, the end product is for users. At the end of the day, it's a developer experience kind of thing. If I'm doing the Python language, I need to make sure that people enjoy programming in Python. So we provide the good abstractions, we provide the good speed. We try not to break things when we make implementations of some of the faster things that we are introducing. But on the other hand, like in my job at Bloomberg, is called developer experience. So the idea is that at the end, developers have a good experience, and developers are people, or at least today. So at the end of the day, it's hard because like what makes people happy, right? That's a hard thing to say. And like for instance, will people enjoy, I don't know, faster runtimes, but if we triplicate compile times, I don't know, will that make them happy? Who knows? And different people have different priorities. In the Python world, is quite obvious, right? Like for instance, there is people who love to have some static typing in Python, so they love typing and the typing world and all the thing that goes around it. But a lot of people don't, and actually they see those things and they say this is confusing and it's annoying, and why the language is kind of getting more complicated on these realms. And both sides can be true, can be correct. I mean, depending, right? But like at the end of the day, that is the hardest thing, right? Like it's not that there is the problem and then there is the solution, and the solution is very hard, and then you need to go to your room and spend like 2 days surviving with a monster or something, and then I solved the problem. At the end of the day, that is the easy part, because as long as you understand the problem and there is a solution, it's just a amount of like giving enough time. The problem with people is that there's not a solution, so you need to kind of understand what's going on and like who wants what, and at the end you need to like make a decision most of the time over different things in the Python world about like everything, right? Like new syntax or new additions to the standard library. And in the Bloomberg world is like, should we spend time doing this or that? Or like, what about if we introduce this hack? Is that going to be maintainable? So it's a lot of hard questions that are inherently human, and that is hard because like there is not a correct solution. It's just a bunch of things to decide on, and it's just compromises all the way. So you need to have some good experience, and some set of the users are not going to be happy, and then you need to deal with that. So that is the hardest problem for sure. And I think That's my opinion, but I think at the end of the day, most hard problems on computer science are human problems after all.
Yeah, so I know that you've been an integral part of the Python Steering Council, and I know you also mentioned this. Could you explain the role that it plays in the Python community?
Yeah, of course. So the kind of the Python Steering Council was born when the creator of Python, Guido van Rossum, kind of decided for different reasons that he didn't want to have like the leadership of the project anymore. So at that time, what happened is that the community or the core developers who are kind of the group of people that decide what goes into Python and review pull requests and basically the people that have merge privileges on CPython. So we kind of do the work and whatnot, but like at the end of the day, big changes were decided by Hido. Like we make proposals called PEPs, that stands for Python Enhancement Proposals, and kind of Hido look at them and say like, okay, this is good, this is bad, like this goes, this that. So he kind of, among other things, approval of that. And at some point he decided that he didn't want to do that anymore. So we kind of have some discussions around, okay, how are you going to organize the project and the community after this? And we came with this idea of the Python Steering Council, which is a group of 5 people. They don't need to be core developers, although core developers are the ones that vote for those people. And this is refreshed every year. So, there is candidates at the end of December every year, and the core developers vote and 5 people are elected. There are some rules, like for instance, there cannot be more than 2 people from the same company and things like that. But at the end of the day, we together kind of decide on these things and more others. So for instance, we decide on like what goes into Python and what doesn't, what new features are added, especially when they are big. When they are, when core developers kind of reach an agreement, we kind of mediate. So we say, okay, we don't know what to do, but now the steering council says that, we are going to do this. Sometimes there is proposals to have so there are some rules that we need to follow, but sometimes someone says, okay, actually it makes sense that we don't follow these rules for this case because yada yada yada, and then the steering council says, okay, we give you an exemption for this, or we don't. We do things like enforce the code of conduct, for example, as well. So for instance, if some core developer, unfortunately this has happened 1 or 2 times, but if some core developer or some member of the community that is related to the Python core developer team kind of misbehaves or doesn't follow the code of conduct, which we take very seriously. So we are the ones that have the power to remove the commit bit or ban them or whatever, or decide what to do. We kind of take the last word. There is of course a code of conduct committee, which we are not in. They give us a kind of a recommendation what to do, and then we either apply the recommendation or a harder action or a softer action depending on the circumstances. But yeah, basically it's a kind of an organizational thing. We take a lot of decisions, but we also do a lot of bureaucracy and administration. And we are elected every year. So that's what the steering council is.
Yeah, I've also read that you're an important open source contributor. How does work in a corporate world compare to open source contributions? And how would one convince their company to allow them to devote time to things such as helping contribute to a project like Python?
Right, that's a very good question. There is differences for sure. So working in a company is very different from doing open source in some ways. In some ways, for example, one of the biggest ways is that in open source, people are volunteers, so you cannot control what time they dedicate to projects. So you can say, I don't have the time to do this, and you don't do it. So because you work on what you like. You can evolve to take some responsibilities. For instance, apart from being the Python Steering Council, I'm also the Python release manager, so I release Python. So when you download Python, that's something that I place there and do all the build process. This is quite time consuming. It's just pushing a bunch of buttons. It's just that it's 5 hours of pushing buttons. And I need to do it because if I don't do it, nobody does. So I cannot say, oh, I don't have time today because I promise that I will do it. But like normally you take some responsibilities if you want to, but it's always if you want to, right? And you can always say, I'm not going to work on this because I don't like it. And that's how it works. And, from this point of view of, dealing with big projects and organizing big changes, that can be a bit tricky because like you cannot force people to do things that they don't like, or like sometimes they're in the middle of project, they say, I don't know, I'm going to vacation, and then what do you do, right? Because they are not doing what that. So in open source, that is the deal. And if you go to some project and say, hey, you need to change this and that, they can say no, and that's fine. Because they don't have time, or they don't have resources, or they say you do it if you want. That's another possibility. In the corporate world, is very different because you cannot say that because you're being paid to do things. So if well, it depends on how it works. For instance, at Bloomberg, that is not like this. But let's say hypothetically that your boss says you need to do this, then you do need to do it, right? And that is important. And the difference is not more about like what you do, because at the end of the day, it's never like, I mean, I suppose some jobs are like this, but like normally it's not like your boss comes to your room with like some sacred light and tells you need to do this, and then you do it. Normally it doesn't work like that. But like the idea here is that, especially when there is communication and collaboration between different teams in the same company, at the end of the day, the objective is that the company has the best experience together. So if you go to some team and say, hey, I need you to do this, then they cannot just say no, because at the end of the day, the company has a need. This needs to be solved some way or some other. So you cannot just say, hey, we are volunteers here because you are paid for to do that. So that is a trickier thing, because then the coin is not like effort, because at the end of the day, you agree that you need to do it. The coin here is priorities. It's like, should we do this or should we do that? Or like, how do I convince these people so they do this before this other thing, right? And that is a major difference. That happens also in open source. It's just that you don't need to deal with the kind of uncertainty that maybe these people don't want to do it because they are not interested on, right? So it's different kind of dynamics. At the end of the day, it's knowing people, and all the problems are people problems in this regard. So it's, how do I convince people? How do I convince people that this is going to be good for everyone? Should I talk with these people managers or to them directly? So there's a lot of things but that is a major difference over what it is. In my case, my kind of job is very similar to open source, because half of it is open source, with the difference that when you do open source as part of company time, you need to be aware that you are representing your company in that time. So it's not like I'm Pablo doing my open source now is I'm Pablo, who is also a Bloomberg employee. That is very important. Most big companies tell you this already when you join. They say, well, for instance, this is a joke, right? But like, I think it kind of shows very well what I mean. They tell you cannot get now into bar fights, because if before you get into bar fights, it will say mysterious person fights two people to the death in some bar. That is okay, I mean, if you like to do it. But like, now it will be Facebook employee fights two people to death, and then what's going on, right? Like, so at the end of the day, when you're representing your company, you are subjected to more pressure and more scrutiny. So you cannot tell people you're stupid, right? Even if you think it, right? Before, is you just saying you're stupid and people will think that you're an asshole, or maybe not. But now it's different. Now it's like Bloomberg employee tells people you're stupid, and that looks quite bad. So you need to be like, you need to have a lot of patience. And this connects to the second part of the question, which is, how do you convince your company to allow you to do open source? Well, at the end of the day, you need some collaboration with your management. So they need to understand the value of open source, because if they don't, there's not much hope there, unless you kind of educate them on like, okay, we use a lot of open source for free. So at the end of the day, it's good if we give back. Maybe there's a bug that affects us, so we can solve it for everyone as well, right? So something like that. Who knows? But that's the first step. Sometimes it's the hardest, sometimes it's the easiest, because like, if your company is already using, most companies now are using open source, so it's not difficult to show them that they already depend on the labor of volunteers. But after that, it's just a matter of trust, right? Like, you need to prove that you can do your job and open source in a way that first you're going to represent the company quite well. That you can, because at the end of the day, they will lose some visibility over what you're doing, because now you are doing it in the wild, as opposed to doing deliverables and whatnot. So there is some trust that you are going to be resilient enough, and like you're going to know how to organize yourself to pick like high impact things, and that the things that you're going to do is going to also like show into the company in a good light and things like that. So there is a lot of trust that needs to be done. That's, for instance, it took me probably 2 or 3 years for me to build this trust with my management chain until they let me, do open source, even if I was already doing very well. But yeah, I would say that first is to convince your management chains of the value of being involved in the community. It may be many things. Sometimes you may depend on a feature that they are going to remove, and now it's good that you have someone in the community that I can say, hey, we use that feature, please don't remove it. And that is an easier thing to do if you're involved in the project, right? So if you are like, let's say you use a lot of Redis, so it will be good that maybe you have some special needs, so it will be good that you contribute to Redis and then say, hey, we have these problems, maybe other people also have these problems, what about if we do this? And then maybe your work can be used by you, but also by other people. So at the end of the day, there is value in that, but only if people understand the value of being part of the community and contributing to the community, and b they trust you to do it in a way that benefits you and the company. There is more tricky things, but this can get super long, so I'm going to stop here.
Thank you. So this is more of a general question, but I know that in the last decades, Python has been a language that's been really widely used. It ranges from being one of the first languages that students learn in middle and high school, all the way to being a choice environment for developing top machine learning libraries. So what is it that makes Python so successful?
Well, it changes depending on who you ask, because people have different views on the matter. I think it's a combination of many things. One of them is that it's a very high level language, in the sense that there is a lot of aspects of computing that you don't need to learn at the beginning. So the barrier of entry is lower, let's say, than a compiled language. Right now, you need to deal with all this. You don't know anything, especially for, it's not only all like kids learning how to code. It's also like physicists, right? Like, hey, I'm a physicist, I can solve like super hard equations, but I don't know how to code. So if I need to start learning, then what is the barrier of entry, right? Let's say your first language is C++, then you need to learn all these things like typing system and compilers and linkers and this and that. It's just too many things just to print hello world to the screen. So that's kind of like not a good experience. So a lot of people see that as like, wow, man, ooh, this is quite hard, right? Python, on the other hand, but also many other interpreted languages, they have less things to worry about at the beginning. So that is one simpler thing. Especially Python has a good combination of many things. One of them is that it has a very rich ecosystem. So it's not only like it's very easy to just open Python and start doing things. But first, the standard library comes with a lot of things. So you can do things from socket programming to like sub processes to send emails to the screen without having to install anything or to worry about how do we install this, right? But then apart from that, if you say, okay, I do solar physics, for example, I don't, but like, let's say you do, right? So I need to solve these solar physics problems. Well, it turns out that because Python is used by so many people, maybe there is already a package that do this. Probably it's called SolarPy or something. And then you install that thing and then you have it solved there, and you don't need to code that thing yourself, right? Or like, let's say you want to I don't know, analyze some data. Well, there is a lot of like pandas and numpy. So the idea here is that not only because of the language, but also because the ecosystem, you have a very low amount of time until you have some step towards what you want to do. Because in other languages, it's like, okay, I want to achieve this high level thing, right? I want to solve this equation, or I want to know which is the worst, restaurant in London, because I have some data and I want to, sort by something and whatever. If you are forced to deal with sub problems that are not directly towards your goal, like for instance, oh, I need to sort this table. How do I sort the table? And then sort the table. Oh, now I need to. Now you are like, oh, what I was doing. So like you lose from your goal. But in Python, most of the time, it's like, okay, I want to achieve this, and the path to do that, okay, it has maybe some wobbly line, but at the end of the day, because there is libraries that already do most of these problems, or because you're not going to have to deal with a lot of shenanigans of the language, it's going to be very easy, and you're going to feel very productive because you are always on the realm of the things that you want to do, without having to deal with like problems, right? Even very hard things like, I want to find the shortest path between these two cities. That's the freaking salesman problem. But like, there is a ton of libraries that do it, so you don't even need to know even what that problem is, right? Or what is MP complete, or what is the best way to solve it, because it's done. It's probably very fast already. This also happens in many other languages, but then Python also has two killer things that are super important. One of them is that it has a very, very, very concise syntax. Maybe not like it used to have a very concise syntax. Now it has that plus a bunch of other things, but you don't need to learn those. So the syntax, at least the basic syntax, is very simple. So it's very easy to just start doing it, because there is a lot of concepts that are hidden from you, or they are not so in your face. Like, for instance, there's no curly braces. It forces you to have indentation. There is a lot of like syntax sugar for many things that are quite annoying to do in other places. It mostly reads like pseudocode or English even, so that's why a lot of people really enjoy coding in it, because it's kind of like almost like writing pseudocode. And the other thing, which I think is, it also links into the ecosystem aspect, is that Python is extremely well to be a glue language. Like, let's say you have this C library over here, like that's been there for 20 years and it's super efficient, right? Like, this happens a lot in the math world. Like, for instance, there is this libraries called BLAS and LAPACK, which are like linear algebra libraries, right? Those will work quite well. It's just that, and very fast, because they are compiled code. Some of them are C and some of them are Fortran. And it turns out that a lot of libraries in Python actually wrap and call into these libraries from Python. So at the end of the day, you can use the speed of those libraries, and then you can do a lot of things and reuse a lot of existing code by using Python. So at the end of the day, you can use Python to kind of orchestrate your whole program, while the heavy lifting is going to be done in compiled languages and things like that. And that has been a super successful model for Python for many, many years. And that is, among other things, why most artificial intelligence work and ML and all that stuff is done in Python these days, because at the end of the day, the libraries are actually compiled code very efficient, because these problems are quite hard to, like, it's impossible to do just in pure Python. It's just that Python is a fantastic language to kind of, join everything and put all the pieces together, even if at the end of the day, the actual computation is going to be done underneath in a compiled language. So all of these things go together, probably make Python one of the best choices for people to learn. But it's not the only one. Like, there is people that learn also JavaScript first because they like webs, right? Like, that is also an interesting aspect. Like, if you are learning how to code, you probably want to do something, right? And at the end of the day, if you want to show something to your friends, well, having a web page that does things is much more impressive than having a terminal that, you introduce some numbers and it gives you some other number, right? Or like, it's less flashy. Like, doing JavaScript can be much more impressive to your friends, because it's a freaking web page and you can click things and things happen, and they can access it to their phone, and that's cool. Like, doing Python maybe less flashy, but on the other hand, you like machine learning, so probably you cannot do it in JavaScript, so you need to do it in Python. Well, I mean, you could do it in JavaScript, but maybe not the best experience.
Thank you. So what is still missing from Python?
Well, it depends on who you ask again. In particular, most, like, Python is a very old language, right? It has like 31 years old. Actually, is as old as me. And I was thinking, I think we were born in the same year, maybe months apart. So the idea is that, in such an old language, you need to deal with that many things, right? Because, okay, so you now have one, if not the most popular language in the world by different indexes. But now it's a very old language, which means that there is a bunch of things that, they are quite older, maybe not as flashy as in other places. And you cannot just change them, because if you change them in very quickly, or if you change it in the easy way to change them, you're going to break a lot of people. This happened between Python 2 and Python 3, right? Like, that was quite a bad experience for everyone, because we changed a lot of things, and that was bad. So when you have an old language, it's different to see the evolution, right? It also happens in C++. Many people say that C++ is too big. Well, the actual modern C++ may be a bit too big, but most of the things that are in the language, they are not now the best way to do things, because they were old. you cannot remove them because people may still use them, right? And in Python it's similar. So there is many things that may be missing from the language, in the sense that, okay, maybe, a much better C API, for instance, which is the way you interface with the language from C and C++ libraries and compile libraries in general, what we call extension modules. So that will require us to do some hardcore changes in the interpreter, but we cannot do them because it will break everyone again. So it will be Python 2 to Python 3 again. It's just that it will be Python 3 to Python 4. So, you could say, oh, there is all these things missing from a fundamental point of view, but the reality of the situation is that it doesn't really matter, because most of them you cannot do it. And that is one of the things that makes our job as Python core developers super hard, because let's say we want to make Python faster. Well, Python is a super dynamic language, which means that it's already very hard to make it faster, because everything can change, everything can be dynamic, and you can put things in the middle, and you need to respect that, and you cannot break that behavior. But also because you need to do it in a way that you don't break people. Most of the, you say, okay, I want to introduce, I don't know, a better garbage collector, let's say. And then you go to all the papers and academy, and then you read everything about garbage collection and whatnot. And then you say, okay, this is the best garbage collector that we could do for Python. Well, it turns out that you cannot use it. You cannot use it because it's such a different algorithm that you're going to break everyone using the old one. And now you have this problem when you need to say, okay, the question is not what is the best garbage collector that I can put here. The question is, what is the best garbage collector that is compatible with the old garbage collector? And that is two things. One of them is a much more boring problem, because now, there is not going to be a lot of research, because people research about the best algorithm, not the fourth best algorithm that is compatible. Like, nobody cares about that, right? So when you are going to go to, all the investigation and the research, you're going to see that most of the solutions are things that you cannot use, because like they are the fastest and the better, but is not compatible with your things. And then you need to solve those problems with more constraints. So it's a harder problem to do, right? Like, now you need to do your own research about, like, okay, what is the best algorithm with these constraints. So it's harder because you have constraints, but also nobody cares about it except you, because like you cannot go and say, oh, I'm going to publish a paper about this. I mean, you could, but like it's going to be less interesting, because people that are going to say, oh, I'm creating a new language, which is the best garbage collector, they don't care about yours, because like yours is not as good as the flashy ones. It's a compatible one, right? So at the end of the day, I mean, it's an interesting problem, because like everybody likes to, talk about like what's missing, but most of the things, I mean, there is a lot of things that we could remove if we could, right? But I don't know. I think a better C API and many of the things that will allow us to make Python faster is things that are missing at the time. But Python is already, quite a big language, and it has a lot of things. So adding more things, it will be quite difficult. So I would say that I wouldn't add many big things. And even if I wanted, it's not that easy as you may think. So weird answer, but that's my answer.
Thank you. So where do you think that computing or open source software development is going to go in the future?
I don't think it's going to change much. Like, maybe there is something to say about, all the talk about artificial intelligence, but I think we are years from something that could impact open source as a whole. I mean, there is some interesting talks, right? Like how these things impact, I don't know, artists and things like that with all this DALI thing. But like, for open source, it's fine. It has mainly been the same way. We are still figuring out ways for companies to participate in open source and to fund these projects, especially since it's kind of weird, right? If you think about it, because think about any industry. Like, let's say, I don't know, dentist. You don't see this weird thing when like most tools are free, and there is a bunch of people that give tools but free, and everybody uses those tools, right? That's not how it works. Like, there is a bunch of people that do these tools, and nobody knows how they do it. So, or like, let's say, I don't know, cars. There is no people like giving away car pieces and like factories and things like that, right? Especially there is no companies using those free things. But weirdly, software is this mysterious place when most companies making big money out of the whole thing, use a lot of open source, right? So they use it's kind of a weird model if you think about it. It's unique because you depend, so your company working depends on the free work of a random people that you never met, and those random people don't care about you technically, or they don't need to, so they can decide to break you, right? So they can decide to change things in a way that is going to break you. And now it turns out that you need to do something sometimes. So you either collaborate with them so this doesn't happen, or that you can tell them, okay, here's a bunch of money to fix the whole thing, and also please like take this into account, right? That may be a model. But all other models, like you never talk with these people, and when they break you kind of like make your own version of the thing, and now you absorb all the maintenance cost of that, which is quite hard. So we are still kind of figuring out how that works, like how can companies behave, but it's such a different weird world compared with other industries that there is not a lot of like places to look for like how this interaction works. So I don't think open source is going to change much. Like people contributing that already contributing. It's true that since like there has been a bunch of open source revolutions meanwhile, but like big parts of the ecosystem had always been working on the shoulders of open source, right? Sure, in the past, people may have used more compilers, for instance, from private companies, but for the last 20 years, most people use GCC or Clang, and both are, open source projects. Maybe Clang started like not being, but like in general, people have always been using open source. Maybe since the GitHub revolution and whatnot, there is a more open source, and there is this social component of open source now. So it's kind of odd. I don't know. Actually, that's an interesting question. You tell me, because you probably have a fresher perspective on the whole open source world, right? So you probably are more, you arrive probably to this world with a fresher perspective than myself. So you probably know better on where it's going. At the end of the day, most people that we have been doing open source for a lot of time, we have been working the same as we have been working in the past, and we still use Beam, and we don't have the cool VS Code things that people use, right? Some do, right? But at the end of the day, we don't look on like how we can evolve open source. We like doing the things that we do, and we have always been doing this way. We learn new things, right? Like we use GitHub and whatnot. But we are not that in contact with like the latest thing, right? Because what we want is something that is stable and that we can work, and is reliable, and we don't need to change it 100 times. So it's kind of weird. Like I don't know. I don't think it's going to change a lot. But maybe I'm making predictions is hard, especially about the future. So I'm not going to make like big predictions here. But if you ask me or press me, I think it's not going to change much.
Yeah, thank you very much for meeting with me and for being willing to do this interview.
A pleasure. I hope it was interesting time for you.
Thank you.